Good day, Mr. Martinella. My name is Giselle D. Alejandre, and I'm going to present my work in Machine Problem 1. I was assigned to do a program for Newton-Raphson Method, and I chose C++ programming language. I use this because this is one of the easiest, and back on my college, this is one of the popular programming platform that we are using. Okay. So first, I'm going to present the algorithm of the program. Okay, so as you can see, I declared the variable xo for initial guess, gx for the test convergence, and xn for the new value of x, and EPS for the tolerance. So there. The program will ask for initial guess, then it will test for convergence. Okay, for the formula of gx equals the absolute value of the product of the function of x and the second derivative all over the square of the first derivative. So there, it must satisfy the condition for gx, which is gx will be greater than 0 and less than 1. So if it satisfies the condition, then it will proceed to calculating the root. Then if it does not, then it will again ask for an initial value of x. Okay. For the root calculation, the formula for the new value of x is equal to the initial value minus the function of x over the first derivative of x. Okay. Then it will compute for the tolerance. It depends on what number or value that I assigned or I assigned for the value of accuracy for the tolerance. Okay. For the formula of getting the absolute error or for the accuracy, it is the absolute value of the new value of x minus the initial value of x. Okay. And if it satisfies the condition, it will print for the root. If it does not, then it will again iterate until it satisfies the condition. Okay. Here's the flow chart. Then I will go for the program source code. So we're going to simulate the program source code using C++. Note that Newton-Raphson method is applicable for both polynomial and transcendental equations. So I'm going to present both example for polynomial and transcendental equation using C++. Now, for example 1, we are gonna compute for the root of a polynomial equation. F of x is equal to x cubed minus 4x squared plus x minus 10. Okay, so let's proceed to the program source code. So here, I used an online C++ compiler so that I can run the program for C++. And here, as you can see, I already defined the function, okay, x cubed minus 4x squared plus x minus 10, and its first derivative and its second derivative. C++ programming language, it is one of the basic programming language. That's why it is not capable of, it does not have a library that is capable to derive any given function or to derive or to have a second derivative or first derivative of any given function. That's why I already defined the function of x here, its first derivative and its second derivative. Okay, so I already defined my assigned value of accuracy, or the condition must satisfy this, or the program must satisfy this condition, which is less than or equal to 0.000001, right? Okay, so this is the function. I'm just going to run the program. Okay, so here, as you can see, input initial value, then solution for Newton-Raphson method. I assign a precision of 4. So every value every computed value should have 4 decimal places. I'll just run the program. So the program should ask for an initial value of x. I'm just going to put 5. So there. The value of gx is 0.339506. So it satisfies the condition which is greater than 0 and less than 1. Now it proceeds in calculating the root, which is equal to 4.3069. Okay. So if this is substituted to the function x, so the value or the function value for this will always be equal to 0. Okay, so as we substitute this value into this function, the function value is equal to 0. As you can see here, the function value is approximately equal to 0. Okay, so there it satisfied the error. As you can see in the last iteration, the accuracy is 0. So here is, as you can see, xi plus 1 minus xi. So here, xi plus 1 minus xi. So it must satisfy this condition. Okay. So there. Here, I already show that any input, any initial value of x that converge, it will compute for the root. But what if it does not converge? Okay. What if the assigned initial value of x doesn't converge? Does it show into the console? So let's see. I'll just run again the program and I will assign another initial value of x. Okay. So here the program asks for initial value of x. So I'll just put negative 0.5. So as you can see, the initial value of x, it is computed for the test convergence. Now, the program asked again for another value of x, then meaning the initial value does not converge. So we just have to put another initial value of x. Therefore, we can conclude that the program is effective for convergence tests. So we can rely on this program for C++ in convergence tests for Newton-Raphson method, for polynomial and transcendental equation. Okay. Now, I already have an example for polynomial equation. Now, let's go for transcendental equation. So I'll just stop this. And I will just modify this function. I'm just going to put a transcendental equation, let's say cosine x. Okay. So what is the first derivative of cosine x? That is negative sine of x. And the second derivative of cosine of x is negative cosine of x. Okay. I just modified the function there. So I'm just run the program again. So there, the program asked for initial value of x, so I'll just put 5. There, it computed for the value of gx. It satisfied the condition. The value of gx is 0.087505. It is greater than 0 and less than 1. So therefore, it computes for the value of the root. So that is 4.7124. Okay, then it's substituted to this function, cosine x, then the function value will be equal to 0. Okay, therefore, as we input any function here. Okay, both polynomial and transcendental equation or combination of this equation, we can conclude that this source code for C++ is effective. It has a convergence test, and it computes for the root, it computes for the function value, and it computes for the value of the gx. We can see here that gx satisfies the condition. Okay. So there. So that's the examples. So here's the source code. Finding or searching for Newton-Raphson method program source code for C++. There's a lot of source code, but it doesn't have any convergence test. So here I found one Newton-Raphson method in YouTube that I already just modified his program, his code. As you can see, it is very simple. This code is very simple for C++, and I already found when I run this program, it doesn't have a table for iterations. So I search for a code that display for the table of iterations. So I found one here, and it also have a precision of 4. It also have, it displays decimal places, 4 decimal places. Okay, and here is the code for here. It can display table for iterations, this code. So I just combine this code, these two code, and I modified it, and I add the convergence test. So here, as you can see, I declared the variables. I add the precision for decimal places. There, I included the convergence verification here in this code. I add here cout so that I can show the table for iterations. There, then I will, for convergence verifications test, I include function of x, the derivative of the function of x, and the second derivative. Then this is the convergence test. Then if it satisfy, I've created an if-else statement. If this satisfy a condition, then it will go to begin root calculation. If not, then it will go back to convergence verification. Okay. Then here, begin roots calculations. Then it will begin, this part begin computing for the root. Here, computing for the root, it will always iterate. Okay, that's why we have count equals count plus 1. And here is the table so that I can show the table of iterations to the console. There. And after that, it will print for the root. Okay, it will print for the root. So there. So that's the source. That is the source code that I have modified from these two source code references. Okay. So that's the Newton-Raphson method using C++ programming language. Thank you. That ends my presentation.